Dear students, today we will start gravitation and these classes for JEE and NEET. Sir, we are in CBSE, sir. Sir, can we? Means absolutely, right? Why? Because concept everywhere it is same. Concept is same, but the level of asking questions is different when compared to CBSE and NEET and JEE. I hope you are understanding, right? So now here I am not going to teach separately. This one is only for NEET and this one is only for JEE. I am not going to teach like that. For example, we will see generally, right? Someone kept biryani for me, that chicken biryani, right? So I'm interested in only rice, so I will eat more rice. No, one person is there interested in more pieces, so he will take first pieces only, correct? No, someone will be there, he will take both simultaneously, rice plus piece, correct? So depends upon our need, so in this I am going to give the full derivations, explanations and important formulas also. So NEET point of view, how much we want, we will see, and JEE point of view, how much you want, you can take, and based on that we will proceed, right? I hope you understood, right? See, now we'll start. See here, before if you want to start gravitation, the first scientist is Newton's law of gravitation. Newton's law of gravitation. So according to Newton, every body attracts every other body. Every body attracts every other body. For example, this is one body and this is another body. So if it is one body and this is another body, so it has to attract towards this one and it has to attract towards this one. That is what Newton is saying. According to Newton, every body attracts every other body with a force which is directly proportional to the product of their masses. That means here force depends upon the masses and inversely proportional to the distance, square of the distance between the two. So less distance, so more force will be there. More distance, less force will be there. Clear? According to Newton, I will write the definition. Every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to square of the distance between them. Square of the distance between them. So try to understand again. What is Newton's law of gravitation? Every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Inversely proportional to square of the distance between them. See now here we will see. For example, here two masses are there. Here this one is M1. This one is M1. I hope it is visible, right? This one is M1 and here one more is there. This one is M2. So here I will write this one. This one is m1, and this one is m2. Distance I will write, this is r. R is distance. That means here two masses are there. Two masses are separated by a distance r. And what is Newton saying? According to Newton, the force between the two is directly proportional to the product of their masses. So force is directly proportional to the product of their masses. What are the masses here? m1 into m2. Force is directly proportional to the product of their masses and inversely proportional to square of the distance. Square of the distance means distance square. Distance square. Now what I will do is I will combine these two. I will combine these two from 1 and 2. 1 and 2. 1 and 2. What we get here? F proportional to m1 m2 by r square. F proportional to m1 m2 by r square. If you remove proportionality, we have to place a constant. That constant is F is equal to G m1 m2 by r square. F is equal to G m1 m2 by r square. Very, very important formula. Right? According to Newton, every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So here, what is G here? G is proportionality constant. What is G? G is proportionality constant. So here, G is called universal gravitational constant. What is G? Universal gravitational constant. What is the meaning of universal gravitational constant? Throughout the universe, you can apply anywhere and everywhere. So capital G value will not change. Capital G value will not change. How much value it is? So G value, G is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. Newton meter square per kg square. I hope you are understanding, right? According to Newton, the force of attraction between two masses separated by a distance is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So F is equal to G m1 m2 by r square. I hope you are understanding, right? Please make a note. Now see here, we already know F is equal to, according to Newton, F is equal to G m1 m2 by r square. For example, here one mass is there m1 and one mass is there m2. Distance is r. Then according to Newton, F is equal to G m1 m2 by r square. No, sir, force is vector quantity, na? So can we express in vector notations? Absolutely yes. Absolutely yes. So now here, for example, in this situation, I am calculating force on this one. Force on m2. So how much distance is there? R distance is there. R distance. So now I want to convert in vector notations. How to write? F bar can be written as, F bar vector can be written as G m1 m2 by r square into r cap, where r cap is a unit vector. What is r cap? R cap is a unit vector. While multiplying with a unit vector, the magnitude will not be affected, but it converts into a vector quantity. Converts into a vector quantity. How it is? See, if I write here V is equal to 10 meter per second. Can you tell me whether it is a scalar or vector? Absolutely, it is a scalar. Absolutely, it is a scalar. But if the same expression, if I will write V is equal to 10 I cap meter per second. 10 I cap meter per second. We already know what is the meaning of I cap. I cap represents unit vector along positive x-axis. Along positive x-axis, which means this speed or this velocity or this particle is moving with a speed of 10 meter per second in the direction of positive x-axis. So hence, it is not a speed, it is a velocity. It is not a speed, it is a velocity. That means while we are multiplying with a unit vector, so here it is scalar. It is a scalar. When a scalar is multiplied with a unit vector, then the quantity becomes a vector without changing its magnitude. I hope you are understanding, right? In the similar manner, so here I wrote f bar is equal to g m1 m2 by r square into r cap. What is r cap? R cap is a position vector. Position unit vector. Clear? And we know what is the formula for a unit vector? What is the formula for a unit vector? Can anyone tell me? In a lower class already we studied, right? In vectors chapter. So unit vector a cap can be written as a bar by magnitude of a. Unit vector can be written as a vector upon magnitude of a. So here if you want to modify again, I will write f bar can be written as, here bar means vector, right? Every time I cannot able to say arrow, arrow, arrow. I will say it is bar. F bar. F bar is a vector. So f bar is equal to g m1 m2 by r square r cap. R cap is r cap is written as r bar, nothing but r vector upon magnitude of r. So it can also be written as f bar can be written as g m1 m2 by r cube into r bar. Like this also you can able to write. Clear? So according to Newton, the force of attraction or repulsion between the 2 point charges, the 2 point masses separated by a distance r is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Square of the distance between them. F is equal to g m1 m2 by r square, where g is universal gravitational constant, value 6.67 into 10 power minus 11 Newton meter square per kg square. Clear? Now see. Now see here. For example, here one mass is there here. I will write it is m1 and here I will write m2 mass. M2 mass. So according to Newton, every body attracts every other body, which means m1 is attracting m2, m1 is attracting m2, at the same time m2 is also attracting m1. I hope you are understanding, right? Here m1 is there, m1 is attracting m2, at the same time m2 also attracting m1. So if you see the direction of force, so here on m1, due to m1, m2 has to move in this direction. Force is acting in this direction, right? So on here it will be there. Force will be. Correct? And on m1, the force will be in this direction. Clear? Why? Because m1 wants to attract m2. M1 wants to attract m2, at the same time m2 want to attract m1. So the force of direction will be this one. Clear? And again, if I will write, try to understand. If I write, this one will be force on 2 due to 1. So here I am writing F21, F21. Force on 2 due to 1. So here it will be force on 1 due to 2. Force on 1 due to 2. Try to understand the words. The meaning of F12 and F21. Force on 1 due to 2. Force on 2 due to 1. Clear? These two are gravitational forces only. These two are gravitational forces. Now if you want to calculate here, F12 is equal to G M1 M2 by distance I am saying it is R square. F12. Again if I will calculate F21 G M2 M1 by R square. G M2 M1 by R. If you see the magnitude of F12 and F21 should remain same. So here I will write F12 is equal to F21. F21. That means both are having the same force of attraction. Both are having same force of attraction. But what is the difference here? Difference is the direction. Difference is the direction. Both are opposite with each other. Both are opposite with each other. So here F12 is equal to F21 magnitude wise. Both are opposite with each other. Clear? Don't get confused. Sir, here heavier mass is there, here small mass is there. Here heavier mass, here small mass is there. So how force will be same? Force will remain same. Clear? For example, here sun is there and earth is there. Earth attracts sun with some force. With the same force, sun attracts earth. Clear? Sun is heavy mass, it will attract with more force, and earth is less mass, it will attract with less force. Means wrong. Why? Because according to Newton's second law, every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. I hope you understood, right? Newton's law of gravitation. So we will discuss it in next class. Thank you.